Okay, here's the problem solving video for problem 2.105. It says find the current I1, and you can see the current I1 labeled on the diagram. And if you look at our circuit, we have one source, a current source, and we have several resistors, so we're going to utilize a problem solving strategy on page 49. Step 1 of that problem solving strategy says systematically reduce the resistive network so that the resistance seen by the source is represented by a single resistor. So if we look at the circuit and look at it very closely, you will note that none of the resistors are in series and none of the resistors are in parallel. So we're not going to be able to do series and parallel combinations in the current configuration to be able to reduce the network. But if we look, for instance, these three resistors are connected in a delta configuration, and if we used a delta Y transformation, we could convert that delta connection into a Y connection, and then we can look and see. Likewise, we could do the same with the bottom, but let's do it on for the top three resistors, and in particular, these all have the same value. So if you go back to the text and look at equation 2.31, you can see, for instance, that R delta is 3 times RY. RY is 1/3 R delta. So now, let's apply a Y delta transformation to that circuit. Okay, so for the calculations then, RY is 1/3 times 18, and that's 6 ohms. Now we can only use this expression because we have identical resistors. We could have done a Y delta transformation on the bottom, but we'd had to use the more complicated formulas. Also, if we transform the bottom, we would lose our current I1, so it's best not to worry with the elements on the bottom. So now, if we do our transformation from a delta to a Y, here's our Y configuration now. So we have 3 resistors connected in a Y that are 6 ohms each. Here's our 2 original resistors. Here's the current I1. Here's a current source connected. It has a value of 3 amps. So after the Y delta transformation, we're left with this circuit. Now, if we note, these 2 resistors on the left are in series, the 2 resistors on the right are in series. So now we can take and combine those in series, and we'll reduce our circuit to the following. We have our 3 amp source. Here's one of our 6 ohm resistors. On the left we now have 18 ohms. On the right we have 12 ohms. Here's our current I1. We still haven't combined it in with anything yet. Now, if we continued on with our problem solving strategy, it would say determine the voltage for the current source. So we could do that. However, to speed the solution up, let's look. We have 3 amps entering that node, and then that 3 amps is going to split in those 2 paths. And let's calculate this current that I'm going to call I4. I'm not going to worry about I1 yet. So by current division, I4 then becomes 3, and since we want the current through this resistor, we'll place this one in the numerator, 12 over 12 plus 18, and this is going to give us 1.2 amps. Now if we look at our diagram, we have I4 defined as shown, and I1 is flowing in the opposite direction, so I1 is a negative of I4, which gives a current of minus 1.2 amps for I1.